All right, so Unit 7 is similarity, but we're going to start with just a reintroduction of ratios and proportions. Hopefully, this will be mostly a review, and it should look familiar to you. So, a ratio is a comparison of two numbers by division. So you might see it in terms of how many games a team has won or lost. So 4 to 6, you might see it like that. You might see it written like this, or you might just see it written out 4 to 6. But as long as we're talking about a ratio, we would say just two numbers by division. Okay, a proportion is saying that there's two ratios that are equal. So I could say 4 over 6 is equal to 2 over 3, right? So adding that equal sign and a second ratio that's equivalent is what makes something a proportion. When we look at proportions, we use the cross product, which again, hopefully you guys have seen before. That's just saying that A times D is equal to B times C, right? We could also say if we know that A times D is equal to B times C, we could reverse it, right? If AD equals BC, then A over B has to equal D over C. Oops, sorry, C over D. So either way, but cross products are what we're going to use to solve proportions. And keep going. All right, simplifying ratios. So here you're just looking for common values. So 75 over 400, it's just like simplifying a fraction. I know 75 is divisible by 5, so is 400. However, it might be easiest to try and find the largest number that 75 is divisible by. So I know that I can divide that by 25, and I can divide that by 25. So I would get 3 over 16. Now, 3 and 16 don't have anything in common, so I'm done there. Okay, this second one's a little bit more challenging because we're converting inches to feet. So feet is the bigger unit, so we want to convert 3 feet into inches. Okay, well, there's 12 inches in 1 foot, right? So 3 times 12, this is really 36 inches. Right? If 12 inches is 1 foot, but I have 3 feet, I just take 3 times 12 to figure that out. So now I want to simplify 24 over 36 and not 24 over 3. Because if I'm comparing, I want to compare same units. So 24 and 36, both divisible by 12. That would give me 2 over 3. And that is simplified. Too far. Okay. So here we're just solving a proportion. So anytime you see this, right, we have two ratios setting equal to each other. So that is a proportion. We are going to cross multiply. So 24 times 35 has to equal 30 times 6x plus 4. And we have to be careful when we do this because we're taking 30 times this expression. So we need to distribute. So 24 times 35 is 840. 30 times 6x is 180x. 30 times 4 is 120. And now I'm just solving, so subtract 120 from both sides is 720. And then that equals 180x. So divide by 180. And x equals 4. Okay, and again, this is not something we would expect you to do in your head. I'm using a calculator. You can use one as well. Okay, but the trick there is to cross multiply and then make sure that you're distributing that 30 to both terms of that polynomial. All right, example 3. The ratio of children to adults at a Valentine's Day parade is 2.5 to 1. So remember, that is children to adults. So if I was going to write that out, let's say I put children on top, adults on the bottom, right? Because it's children to adults. And that ratio is 2.5 to 1. So I'm going to write that as a fraction, 2.5, right? 2.5 children for every 1 adult. Okay? We're going to set up a proportion to solve this. It says there are 1,440 adults, 1,440 adults. How many kids are there? Okay? So I want to set up a proportion. This is an adults number, so adults goes on the bottom, 1,440. That's why writing something out like this is helpful to make sure all of our units line up. Okay, and then I want to find how many kids there are, so that's where my variable goes. You can use any letter, most often we use X. So again, let's cross multiply. 2.5 times 1,440 is 3,660, and that's 1 times X, which is just X. So there we go. There were 3,660 kids at this Valentine's Day party. That is a large party. All right, example 4, we're going to find each ratio and simplify. So first up is shaded to unshaded. So if I look at shaded, that's 4 boxes. To unshaded is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's not right. Do I not? Oh, wait. 9, 10, 11. Yeah. Okay. And 4 and 11 don't have anything in common. 2 goes into 4. That doesn't go into 11. So that one is done. Okay. Unshaded to the entire region. So unshaded we said is 11. The entire region would be the 11 plus 4, which would be 15. Same thing, 11 and 15, nothing in common, so that one's done. We can't simplify. Shaded to the entire region would be 4 over 15. We can't simplify that either. 4 is divisible by 2, 1 and 4. 15 is only 1. Dividing by 1 isn't going to change anything. So that one was pretty straightforward. No real simplifying there. Okay, now to determine, so it's giving us a bunch of numbers here, and we want to figure out which pair of ratios forms a proportion. So in order to do that, we're looking for cross products that are the same. Okay, so we're going to do just a couple of these so you can see what I'm saying here. So it's giving us values for each variable. So P is 12, if I look at A, R is 3, S is 4, and Q is 16. Okay, so I want to figure out, is P over R equal to S over Q? So this is where I look at the cross products. Hopefully right away you can tell that this one isn't going to work because 4 times 3 is 12 and 12 times 16 is not 12, right? That's 192. So those are not equal, so that is not a proportion. Or you could just write yes or no. Okay, so let's look at B. Now it's saying S over P. S is 4, P is 12, and that's going to be equal to Q over R, 16 over 3. Okay, so again, if we look at our cross products, we can see that 4 times 3, 12, say it's going to end up with the same thing. Does not equal 192, so this is a no. Okay, let's look at C. Now it's looking at R over S, and does that equal P over Q? So R is 3, S is 4, P is 12, and Q is 16. All right, this one, at least at first glance, looks like it's a maybe. 12 times 4 is 48. 16 times 3 is 48. Okay, so those are equal, so that would be a yes. Okay, so A is not a proportion, B is not a proportion, C is yes, a proportion. We're not going to worry about D for right now. All right, one more, again, just solving this proportion, cross multiply. Here we're just going to have to be careful because we have x's in both. So I'm going to take 40 times 2x plus 1, and then 27 times 3x minus 1. Now I have to distribute both sides here. So 40 times 2 is 80x plus 40 times 1, which is just 40. 27 times 3x is 81x, and then 27 times 1 is 27. So no different here than what we did at the beginning. We just have x's on both sides. We know how to take care of that. We're going to move this 80x over, get our x's on one side. So I end up with 40 equals 1x, or just x, minus 27. Add the 27 to both sides. And so x equals 67. Last one, we got a lot of x's here, but we're going to treat it the same. It might just look a little different as we start to solve. So I have x plus 2 times x plus 5, and that equals x times x plus 2. Okay, so let's look at this. First side over here, we're just going to distribute this x. So x times x is not 2x, that is x squared. And then x times 2 is 2x. So I get x squared plus 2x over there. All right, this side over here, we have to FOIL or double distribute. Hopefully you remember that term from Algebra 1. So I'm going to take the x times the x, which is x squared. I'm going to take the x times the 5, so that's 5x. I'm going to take the 2 times the x, and then I'm going to take the 2 times the 5. Okay, so I end up with 4 terms, but really these middle terms are like terms. We can put them together. So I get x squared plus 7x plus 10 equals x squared plus 2x. Now, you might be looking at this saying, I don't know how to solve that, but let's just break it down here. Okay? First, I want to get the x squareds onto the same side. When I do that, if I take away this one cancels out too. So it looks more confusing, but it's really no different than what we've been doing. So I have 7x plus 10 equals 2x. Okay, now I want the x's on one side, so I'm going to bring the 7x over because there's only x's on this right side. So I get 10 equals, well, 2 minus 7 is negative 5x. Divide by negative 5, and I get x equals negative 2. And it's okay that we get a negative value here because we're just looking at proportions. If we were solving for a side or a length of some sort, a negative answer might be something that we would not want, but for this is fine. Okay, so again, I know it looks a little intimidating because we have those x squareds, but when you start to actually solve it, those x squareds just drop out and you're just left with a single degree expression or equation that you should be able to solve. All right, so we will do some more practice with that in class, and that is ratios and proportions.